Mr. B here. Hey, we're on to 4-4. This is where algebra gets fun. We're solving equations of the form ax plus b equals cx plus d. Now remember, when we talk about it in this way, what we're saying is a is some number we know, x is a variable, plus b, some other number we know, equals c, some number we know, times x, the variable we don't know. Same x's. If it's in the same equation, it represents the same value of x. And then finally d, which is again some number we don't know. Our goal here is to manipulate this using algebra, the properties that we know, and get it into the form of ax plus b equals c, because we know how to solve that. We've done that before. We did that back in chapter 3. So the first part of this lesson is to look at this type of a problem with a CAS. Again, if you don't have a CAS, then do it by hand. If you do have one or get access one, it's useful to use it just to go through these exercises. After using the CAS, then there's an activity that involves even more work with the CAS. And this is to give you a chance to try things, to experiment with how to manipulate the equation. What might you do to it in order to get the results you want, and give you a sense of how it could work. Then we're going to go into solving it with an algebraic process. And in the algebraic process, you can see that we've got a series of steps. I'd like to see these steps. Please don't skip steps, leave things out. Put it in, align the equal signs, and show me what algebraic properties you are using each time. Show me in their step. You don't need to write it out here, but each time you use a property, I'd like to see that used in the step. So here we've got writing the equation, then we're subtracting 10x from each side. We're combining like terms. We've simplified it we simplify the problem, then we add 5 to each side, simplify that, divide by 6, and then simplify. This is a complete solution. Again, try to align equal signs as much as you can. Work in a column format like this. We check our solutions. Why wouldn't you check? You can verify whether you got it right or wrong. Plug in your result into the original equation and solve it and see whether it works out. We're also going to be going through an equation where we have to do some simplifying before we do anything else. And in this case, we're going to be using the distributive property, and I'll walk you through this guided example in a little bit. Lastly, we've got the comparison type of problem where we've got two different things going on, and we want to know when, and it says in how many weeks will it be before the puppies are the same weight. Well, are the same weight means equal. When will the equations be equal? So we set the two equations equal to each other. Here is the one dog's growth and the other dog's starting weight and growth. We manipulate that to find out what W is, and W then becomes 8 equals W, which is the number of weeks that it takes for them to be the same. We do a check of it. We could also check it by making a table or making a graph. If you put it into a graph on your calculator, you would then want to do the intersection function on your calculator to show where the two lines intersect, and you would get that it would be 8 weeks at 18.8 pounds. Oh, excuse me, 18.8 ounces. Or we could have seen that from a table, depending on which one you decided to do. Well, that's it. I'm going to go through a few examples with you. I'll start off with the CAS work. Your assignment is to do covering the ideas and applying the math. Remember to show your work. Each time you use a property, show me that step. I'd like to see what it is you think you're doing. Good luck with it, and I'll get started on the examples. All right, we're working on the activity here on 4-4. you should have gone through example 1, followed the instructions there with your CAS, and recognize that indeed you could work through to get to an answer. You want to be careful with your signs when you're working through these, but it should work out pretty well. Now the activity here says use a CAS to solve the following equations. So I'm going to help you with a couple of these just to, if you're having trouble getting started. At the end of this help session, I'm going to give you a list of the answers for 1 through 8 so you can compare your work. You shouldn't wait for that. You can check your answer. You get your answer, put it back into the original equation and see if it works. So it shouldn't be a mystery to you. You shouldn't have to wait for me to give you the answers, but I am putting them there just in case you need them. So let's start with number 1. And so we've got, let's see, 3 times z is our variable. We'll use that. Minus 4. And that equals 5 times z. 5 times z minus 23. Now the point in this exercise is to figure out, well, what are you going to do first? And so that's the question for you. You want to gather the variables on one side of the equation and the constants on the other side of the equation. And then once you've done that, then you can worry about the coefficient of the variable and multiply that out from both sides. But so you've got to pick a direction, and you know, it's up to you. You can try different things. So I would say go ahead and pick something right now. Go ahead and try it. Pause this video and take a couple of cracks at it, and then I'm going to go through it in the way I would approach it, which doesn't say that I'm right and you're wrong. It's just simply my thinking when I approach a problem like this. So pause it. Okay, well, welcome back. I hope you were successful with question 1 and you got the right answer, in which case you might want to just buzz on through what I did, but I'll try to go through it pretty quickly here. So first we hit enter. We've got our problem. I like to try to keep things positive for the variable. Why? I don't know. It's just kind of the way it is. So I'm going to subtract 3z from the equations from both sides so that I end up with a positive coefficient of z versus subtracting the 5z. Doesn't really matter which way you go. It's just this is how I'm looking at approaching this. So minus 3 times z, and enter. And so what we've got is I'm left with a negative 4 is equal to 2 times z minus 23. Next thing I need to do is to work on this 23, so I'll need to add that to both sides of the equation. And so I will add 23 plus 23, enter. And so we get this plus 23, and plus 23 minus 4 is 19, equals 2 times z. The next thing I'm going to do is going to multiply by the reciprocal of 2, or depending on your mindset, divide by 1/2. Divide by 2, excuse me. So for me, I like the idea of multiplying by the reciprocal when I'm working by hand, but that is basically dividing by 2. So if I did times 0.5 versus divided by 2, I'm doing exactly the same thing. So I'm going to keep my operations a little simpler here. I'm going to divide my answer by 2, enter that, and I get my final solution, which is that 19/2 is equal to z. This is an improper fraction. It's in fully simplified form. There's no reason to divide into it. If you were to do that and get it into decimal form, we'd find that it would be 9.5 or 9.5 would be equal to z. But these are equivalent statements. You can stop right here. Okay, that's number one. Next, I'd like to take a look at number two in here, just to kind of stay in order. Oh wait, is there one you'd like to go to? Did you look through it? And is there one you want to try to work on before we move ahead? No? Okay. So we'll just do two. And for number two, it is 21 minus 6 times x, 6 times x, and that equals 22 minus a negative 8 times x. Hit enter. And minus a minus, double negative is a positive, and you can see that the CAS has taken the liberty of rewriting this as 21 minus 6 times x is equal to 8 times x plus 22. So it used the algebraic definition of subtraction, changed it to addition, and then it used the commutative property to change the position of the values in the equation. So next I need to pick a direction. I've already kind of told you my preference is to try to make things positive. So in that case, that'll means I'll be adding 6 times x to both sides of the equation versus subtracting the 8x. And so I'll go ahead and do that. So I'll do a plus 6 times x, enter that, and so adding 6 times x to both sides of the equation leaves me with 21 equals to 14x plus 22. Now I'm going to go ahead and I'm going to undo the addition here. I'm going to subtract 22 from both sides. So minus 22, enter, and I get that a negative 1 is equal to 14 times x. Now I need to multiply by the reciprocal of x, the reciprocal of 14, or I need to divide 14 times both sides of the equation by 14. So I'm going to divide everything by 14, enter, and I get a negative 1 over 14 equals x. That's my answer. I'm done. That's complete. So that's your a little bit of help with the activity using the CAS. Go ahead and work through the rest of them. Be aware that you could, for number 6, you could try to look for a way to clear out the fractions if that's going to trouble you. For number 7, you could also clear out the fraction by multiplying everything by whatever you need to do there. And then for 9, 10, and 11, follow the procedures as given. So I will now go ahead and I'm going to give you the answers for 3 through 8 for the for this activity, and you can compare that to your results. So if you it would be best if you were to pause the video, do 1 through 8 at least, and then check your work, and then come on back and take a look at what kind of answers I've presented for you. Okay, here are the answers for the activity in 4-4. We did 1 and 2. Z equals 19 halves. X is, for 2, x equals a negative 1/14. Number 3, p equals 3. Number 4, n equals a negative 5 halves. You may have written that a different way, but I would prefer this one. K equals 82/15. Number 6, B equals 285/7. Number 7, Y equals 1. And number 8, you've noticed I've not written it as a fraction. I put it W equals 28 hundredths. And that's because the problem itself had numbers in it, values in it, with information to the right of the decimal place. Therefore, I'm going to report my answer in decimal notation versus fractional notation, provided that it is a non-repeating excuse me, that it's not a infinitely long, non-repeating, non-terminating decimal, in which case I couldn't make it an inequality. I could only do an approximation. So in that case, I might have to do a fraction. So that's pretty much it. For number 9, it says write a description of the process you can use to solve 4x plus 3 equals 6x minus 8. You tell me what you did. You should know at this point about some approach to solve this problem. But this is a case of writing it down in English and describing your procedures. Then it asks you to use the process described in question 9 to solve for x without a CAS, and then check your solution with a CAS to see whether it's true. What you should have gotten for 10 was x equals z plus 3. That's all over a fraction bar, and underneath that is 2. So what you would have for number 10, I'm going to go ahead and write it up here. Number 10 is going to be x equals z plus 3 all over 2. That's what you should have ended up with after having run that through. Then it asks for number 11 for you to solve the 4x plus t equals 6x minus z for x without a CAS, and then check your solution with a CAS. Solving it for x means that you're looking for it to end up with x equals everything else that's in there that can't be resolved, and that was going to be z plus t all over 2. Okay, that's it for the activity. I'm going to provide a few examples of things we could do. In these cases, I'm going to do these by hand, so there'll be problems that we can work with using our equation skills and solving skills. So our first example, so this is 4-4. Example 1, extra example 1. Whew. Extra. There we go. Extra example number 1. And here we're going to solve 21x minus 9 equals 11x minus 39. So my first step, again, I'd like to gather values on one side or the other. I'm looking for how I might make this perhaps positive for these my coefficient of x, and it looks like subtracting 11 from both sides works. So I have minus 11x plus 21x minus 9 equals 11x minus 11x minus 39. So what I did in this very first step was to add the opposite of 11x to both sides of the equation, and that's the addition property of equality that tells me I can add the same thing to both sides of an equation. So 11x, a negative 11x plus 21x gives me 10x minus 9. 11x minus 11x is 0, and that's minus 39. So now I'm going to go ahead and add 9 to both sides of the equation. Addition property of equality again. 10x minus 9 plus 9 equals a negative 39 plus 9. So 10x equals a negative 30. Multiplying by the reciprocal of 10, 1 over 10 times 10x equals a negative 30 all over 10. 1/10 times a negative 30 is negative 30 over 10. This becomes our 1, so x equals, the zeros cancel out. I got negative 3 over 1, which is a negative 3. This is our answer. I would check this by putting this back into the original equation and verifying that it works out to give me these two equations equal to each other. That's our first extra example. I'm going to head on to the next one. And in this next one is a little bit more complicated. This is our extra example number 2, 4-4. Extra example. Hey, I spelled it right that time. Number 2. And here is our work to be done. Negative 13 minus x minus 2 equals a negative 3 times x minus 3. And that's it. So negative 13 minus x minus 2 equals a negative 3 times x minus 3. Now when we're dealing with this, this is as though we have a 1 here. This is minus a 1 times all of this. And I'm going to go ahead and my first thing I'm going to do is I'm going to rewrite this as subtraction. So plus the opposite of whatever x minus 2 equals. That may help me to remember that I have to multiply this negative times everything in here. That's my first step. I'm going to want to get rid of these parentheses, and so I'm going to do that by using the distributive property. Negative 13 minus 1 times x is the opposite of x. A negative times a negative is a positive 2. So this opposite, the negative 1 times x is the opposite of x. Negative 1 times minus 2 is plus 2. Negative 3 times x is a negative 3x. A negative 3 times minus 3, negative times a negative is a plus 9. Now I'm back to where I was earlier, where I need to pick a direction, go ahead and move things around. So I'm going to add 3x to both sides of the equation. So I'm going to do a plus 3x plus 3x. Well, it looks like what I should have done too is to combine these two together. So I'm going to go ahead and do that all in one step. I hope I can get it right. I'm going to start over here because I think I can get this right. Negative 3x plus 3x is 0x plus 9 is just 9. Negative x plus 3x is 2x plus a negative 13 plus 2 is a negative 11. 2 from 13 is 11. Negative 13 has the largest absolute value, so its sign rules. So 2x plus a negative 11 equals 9. Now I'm going to add 11 to both sides of the equation. 2x equals 9 plus 11 is, what does that work out to be? Oh yeah, 20. Divide both sides by 2, or multiply by the reciprocal. 1/2 times 2x equals 20 times 1/2. 2 over 2 is 1. 1 times x is x. X equals 2 goes into 20 10 times. We have our solution that x equals 10. Okay, 4-4, extra example number 3. The length and width of a rectangle are x plus 4, x minus 3, respectively. The lengths of the three sides of a triangle are x, x, and x plus 6. Determine the value of x for which the perimeters will be equal, and check your answer. Well, often in something like this, something that's good to do is just do a quick look at a figure that would be give us an idea of what's going on. So I want to get a quick rectangle here, and it's not an art class, so we just try to get it right, but I'm okay with something that's a little less than perfect, as long as it represents what we're looking for. So this is going to be our x plus 4 side. This must be x minus 3. So that's our rectangle. Our triangle is isosceles because I have two sides that are the same length, and not equilateral because I have two things equal and then I added 6, so it's not going to be all the same. So this will be x plus 6, this will be x, this will be x. Well, what constitutes the perimeter? The perimeter of a rectangle is how far is it if you walk around the outside of this. So I go x plus 4 distance here. How did I get x minus 5? Wow. X minus 3. Okay. X minus 3 here. Then I go x plus 4 again, and then I go x minus 3. So what are our equations going to look like when we write this down? Well, we're going to go ahead and take a look at what those might appear like. And so for x plus 4, x minus 3, I've got two x plus 4s, so that's 2 times x plus 4 plus 2 times x minus 3. So here's my expression for the perimeter of the rectangle. I'm being asked to determine the value of x for which the perimeters will be equal. Equal means, you know, equal sign. So now what's the formula for the parameter for the perimeter of the triangle? Well, as I walk around it, I do go x plus 6, I go x, I go x. So I've got x plus 6 plus x plus x. So I've now written two expressions. I've set them equal to each other, and now I've got to solve for x. And this is back to the simplifying, combining like terms. So in my first step here, I'm going to go ahead and simplify these two expressions, and I'm going to combine like terms over on the right side. So 2 times x would be 2x. 2 times 14 plus 8. And then I've got this next one is plus 2 times x is 2x. 2 times minus 3, I'm going to make that plus a negative 3. 2 times plus a negative 3 would be plus a negative 6. And that's going to equal, I'm going to combine these x's. I got one x, another x, and a third x, so that's 3 x's. 3x plus 6. Now I need to combine like terms over here, and 2x plus 2x is 4x. 8 plus a negative 6 is 2. And I've got that 4x plus 2 is equal to 3x plus 6. Need to pick a direction. You know my preference in this case is to keep the variable positive. And again, I repeat, that's just me. If you're more comfortable doing it differently, that's fine. You got to pick something, and this is what I choose to pick. So I'm going to subtract 3x from both sides of the equation. And we'll go ahead and get 3x from 4x is just x plus 2. Ooh, that's a horrible plus sign. Okay, plus 2. equals, well, 3x from 3x is just 0x, and that's then plus 6. Now you'll notice I didn't write out the line where I did the subtraction. I do that, I'm pretty confident I can get my calculation right. Sometimes in not doing that, you find you don't do things right. That perhaps instead of subtracting 3x, you add 3x to both sides, in which case you have 7x here, and you assume that 3x plus 3x equals 0x, even though it doesn't. And so you could have blundered and not seen it. So if you're having trouble with this, what to add, what to subtract, don't take this little kind of a shortcut, or what I call a logical leap. Now if you look at it, can you tell what I did moving from this one line to the next line? Can you see what happened to the equation going from here to here? And that's a logical leap. It's something we can track and we can understand it. And as you become more comfortable with your algebra, we begin to take these steps where we kind of do things in our head real quickly and then write it down. But you want to limit how much of that you do, and you don't want to do it if you're making mistakes. Next step is we're going to subtract 2 from both sides. 2 from 2 is 0, so I'm left with x. 2 from 6 is 4, and I'm left with x equals 4. Now part of this question said to check it. That means I would like to verify that these two equations, in fact, equal each other. So I'm going to go ahead I'm going to kind of dim this down a little bit. Going to get rid of that one. And I'm going to, open up another page, because I want to be able to put this back in for my check, and we'll go right up here with it. And so I will have that 2 times 4 plus 4 plus 2 times 4 minus 3 equals 4 plus 6 plus 4 plus 4. And I can go ahead and see 4 plus 6 is 10, plus 4 more is 14, plus 4 is 18. 2 times 4 is 8, plus 8, plus, I think I left something off here. I left off a 2, huh? That's horrible. I'm glad we caught it. 2 times 4 is 8, minus 6. 2 times minus 3 is minus 6. 8 plus 8 is 14. 14, wow. 8 plus 8 is 16. Plus 8 more is 24. 24 minus 6 is 18, and I get that 18 equals 18. My equation checks. So that's it for our examples here. You can continue on to work through it. Do look through example 4. Your work again is covering the ideas, applying the mathematics. Be diligent about it. Be honest with yourself about your work. If you have questions come in, it's okay to be confused. Okay, we want to work together to become unconfused, but it's okay to be confused about what's going on. We just keep trying until we get it. See you on 4-5.